Hello children, welcome back to chemistry class. Today we are going to discuss our next topic, that is chemical properties of boron. Chemical properties of boron. So in this we will see what are the properties of boron. So let us see. Boron, if you see boron, except boron, other elements of this group are metals, metallic character, increases down the group. Except boron, other elements of this are metals, metallic character increases down the group. Boron is non-metallic crystalline inert hard solid, black color solid. Okay students, its amorphous form is more reactive. Aluminium reacts with atmospheric air. Forms oxides on the surface, which makes it protective. Next, we see indium, gallium and thallium are soft metals, metallic character increases down the group. Boron forms covalent compound. While others form ionic compound in aqueous solution. Like this, let me say here AlCl3, when it reacts, it forms O6 plus 3. So it is ionic compound. Except thallium, all other elements form compound in trivalent form. Except thallium, all other elements form trivalent compound. Trivalent compound in which central metal atoms octet is incomplete, and act as Lewis acid. The nature of Lewis acid, the nature of Lewis acid formation decreases down the group. Decreases down the group. So if we see like boron, it forms BCl3. Okay. So here, if other we take AlCl3, GaCl3 and InCl3, so their Lewis acid nature decreases down the group, or we can say Lewis nature decreases as the size of atoms increase. So these are the properties. Let us see more properties. Most of the compounds are easily hydrolyzed in water and they form ionic compounds. So that we will not write. So we can write most of the compounds. This one compound that is be formed like this. Compounds are easily hydrolyzed in water and they form ionic compound like this. Here it forms this compound. This, that is tetrahedral. AlCl3 react with water, it forms octahedral. It forms octahedral compound. Means ionic compound. So most of the compounds like that BaCl3, AlCl3 are easily hydrolyzed in water and form ionic compounds. So here it is octahedral. So they form ionic compound. So next is reactivity towards air. Next is reactivity towards air. Reactivity towards air. So boron is non-reactive on moderate temperature. Aluminium form oxides in air around its surface, so that protect the aluminium from further attack. So let us write boron is unreactive at normal temperature. Unreactive at normal temperature. Aluminium reacts with air, forms oxide layer on the surface, which protects further attack. Boron and aluminium on heating form E2O3 type oxide and En type nitride. Like this, B plus, so it will form what is B2O3. Like this, and aluminium react with 3O2, it forms L2O3. So we can take 4 and 2 like this. And in air there is nitrogen also, so they react with nitrogen and they form ammonium nitride. Boron react with nitrogen, it forms boron nitride. So they form like this compound. The acidic nature decreases down the group. The acidic nature of these oxides decreases down the group. Decreases down the group. we have seen here that acidic nature decreases down the way. So this is B2O3, L2O3, INO2 and TL2O3. So this is acidic, that is a butyric, and that two are basic in nature. So we discuss. Next is reactivity towards halocene. Reactivity towards halocene. So next is reactivity towards halocene. What is reactivity towards halocene? These elements react with halocene to form trihalide. Trihalides. Form trihalide. Trihalides like this. B plus X2, they form 2 DX3. Al plus 3X2, they form 2 AlX3. That is compound they form. Next is a reaction with acid and alkalis. Reaction with acids and alkalis. So let us see how does they show the reaction. Boron doesn't react at moderate temperature, but at high temperature it reacts with some acids and mixture of acid and form boric acid. So let us see what does it happen. Boron react with mixture of HNO3 and concentrated HCO4. It forms S3 BO3 plus 3NO2. So generally it doesn't react with at moderate temperature, but it reacts at high temperature, and like this it reacts with a mixture of H2SO4 and HNO3 and gives what is boric acid. Boron also reacts with fused caustic soda fused alkali like NaOH and KOH forming the NaOH or KOH forming the corresponding borates. So it react with borates and they break oxygen. Here to be Na2CO3 plus NaNO3 gives Na3 NO3 plus NaNO2 plus oxygen. And next is, as you know that aluminium react with mineral acid and with alkali also. Aluminium react with mineral acid and alkalis, means in both cases it forms salt. So that we have as amphoteric acid. Amphoteric nature it shows. Aluminium is dissolving. Aluminium is dissolving in acid as well as alkali. Aluminium is dissolved in acid as well as in alkali. It shows amphoteric character. It shows amphoteric character. Means it is amphoteric in nature. Okay. So let us see. It react with HCl and it form Al2Cl6 plus 3H2. Here that is acid. And next step, it react with alkali. And it forms this compound NaAlOH whole 4 like this. So here this is base. Okay, so it shows the amphoteric nature, means alkali is dissolved in acid as well as in alkali is dissolved in acid as well as in it shows the amphoteric character. And next, if we say gallium, indium and thallium dissolve in dilute acid liberate hydrogen. Indium, gallium and thallium is dissolved in acid liberate hydrogen. So these are the characteristics of P block boron family elements. So students, we have discussed the chemical properties of boron family. Okay students, keep watching my videos. Thank you so much.